The bounty of the oceans has supported mankind for generations upon generations. But early sailors and fishermen only knew what they could see near the surface or pull up from beneath it. Today, we have a better understanding of just how plentiful and diverse sea life is. There are an estimated 10 billion tons of fish in the ocean, from some 212,000 known marine species. Billions of microscopic creatures make up the base of this vast food chain. With ocean sustainability a major concern, scientists and policymakers are less focused on discovering the ocean and more focused on observing and sustaining it. NeXOS, observations supporting ocean sustainability. The wealth of the ocean lies not just in its creatures, but also in its energy and mineral resources. All told, the ocean's business activities are estimated at 2.1 trillion euros per year, which would make it the fourth largest global economy. But there are impacts, from humans as well as from the changing environment.
Monitoring the ocean is very costly in general. The number of variables is enormous and the number of interests is very high as well. This has led to European directives like the Marine Strategy Framework Directive, which calls for the monitoring of the environmental status of the oceans and the marine waters of Europe.
So good environmental status is a way to express that our seas remain healthy and that our uses are sustainable. But of course, what does that mean in practice? The directive sets out 11 areas, or the so-called Ocean 11, which are 11 descriptors that look at different aspects of the marine environment, whether it be biodiversity, or the food web, or the fish stock that we're using.
Now, the next phase is to try to put all the measurements to get a proper observing system that's continuous, sustainable, going for Europe.
So in ocean observing, we're looking at 3 different opportunity areas. One is platforms, that is the way we access the ocean. But the exciting space that I see coming up in the next decade is the sensors, because the sensors are going to enable these platforms to use in ways we cannot imagine today. So I really think a big push in our capability of observing the ocean will come through new technologies and new sensors.
NeXOS has developed next-generation sensors with small size and low power for fixed and mobile observing systems. One or more of these sensors can be deployed on undersea and surface-level autonomous vehicles or on deep-sea observatories.
This is a legal requirement that states have, and so this is an important application for the A1 and A2 sensors. One of the important descriptors of the Marine Strategy Framework Directive is numbered as descriptor 11. That is input of energy from anthropogenic activities into the ocean medium.
Human activities create noises in the oceans from ships, energy generation, and other interactions. And sound is an important part of the Marine Strategy Framework Directive, or MSFD, falling under descriptor 11.
Input in terms of technology coming from NeXOS is to be able to pre-process the data and reduce the cost and enable that possibility of measuring sound in the ocean without this bottleneck.
Using a special signal processing board joined with state-of-the-art hydrophones, this NeXOS acoustic sensor A1 can detect and process a large spectrum of sounds, from landslide rumbles to bioacoustics sources. A1 has been demonstrated on a Sea Explorer glider in Norway, on a PROVOR profiling float in the mid-Atlantic, on a towfish installed on a surface wave glider, and as part of the A2 sensor in the Mediterranean. The NeXOS A2 is an acoustic network of precisely synchronized digital hydrophones. There is a central processor for real-time localization of sounds. The A2's shape is adaptable. Here, it is configured as a cross with 10-meter arms and the hydrophones positioned at the ends. There are also MSFD descriptors for chemical pollution and the ocean's abundance of microscopic creatures. For these cases, NeXOS developed a second type of sensor for observing light in the ocean.
We successfully developed a couple of sensors targeting essential variables for the marine realm. These essential variables can be things like oil in the water or phytoplankton, which is algae, and also things like chemical parameters addressing the carbon cycle.
Fluorescence is one of the processes used by NeXOS to monitor the ocean. Fluorescence occurs when light stimulates materials to emit their own signature blue, green, or red color. So far, monitoring algae or CDOM with fluorescence has required multiple sensors. NeXOS has reduced that need.
What is key to the sensors that we developed is that they are not only measuring what they are intended for. I mean, that's the first thing you want as a customer. The sensor should measure the key parameter that you're interested in with the accuracy that you want. But what is really key to the NeXOS approach is that all of them are interoperable and they have standardized protocols.
For long-term operations, biofouling of optical sensors is a major issue. NeXOS has a new solution for biofouling.
As long as this active coating is producing biocide by electrolysis, as long as it works, the optics is 100% protected.
The applications for monitoring chemicals and microscopic algae are two examples of applications for fluorescence sensors. However, there are times when the density of contaminants is not high enough for these sensors to work. For lower densities, an alternative system from NeXOS uses an integrating cavity to increase sensitivity. These were demonstrated on a recent science cruise on the research vessel Heinke. Monitoring the carbon cycle is another key challenge in addressing the Sustainable Development Goals adopted by the United Nations. NeXOS developed the Seabond-2 sensor to gain a more comprehensive understanding of the ocean's carbon chemistry. The sensor was fielded on a sailbuoy and also on the Heinke research vessel to collect data pertinent to the changing climate. Monitoring fisheries is also a high priority, and it too requires new sensors. NeXOS developed two of them, one to monitor oxygen and the other for chlorophyll. The NeXOS EAF sensors have been field tested with fishermen in Norway, France and Italy. You can see the sensor on the outer door of this fishing net system. As part of the RECOPESCA system, these sensors provide the environmental information needed to manage fish stocks. Kjell Nedrehaus of the Norwegian Institute of Marine Research has been working with fishermen and boats for 40 years. He relates his experience.
We give them something back, and technology is a very concrete thing. And they like to be in front of technological development. So your project is definitely contributing to that.
For the EAF fisheries system and other applications, it's crucial to have multiple sensors that can work together effectively.
But what is really key to the NeXOS approach is that all of them are interoperable and they have standardized protocols.
NeXOS interoperably connects users to sensors and platforms. In addition, the PUC protocol provides sensor information to the platform and the user. This capability is part of all of NeXOS's sensors and users can work with any of the sensors in common formats.
We were using a set of standards, mainly OGC standards, to develop a software architecture that enable an end-to-end plug-and-play architecture.
NeXOS worked closely with its small enterprise partners to move toward production.
To be able to be bankable, you need to show you've got the intellectual property, you've got to be able to show who the competition is, you've got to be able to assess the market. Sometimes there could be alternative markets, but you have to focus on one or two because you have to demonstrate to this market that you can meet it.
With NeXOS's introduction of this suite of lightweight, low-power and fully interoperable sensors, the time is now to transition from research to operations.